Welcome to our comprehensive video on soil investigation for foundations. In the context of India's rapidly growing infrastructure, where over 70% of the buildings that will exist in 2030 are yet to be built, understanding your soil is more critical than ever. In fact, studies show that in India, soil related issues contribute to nearly 30% of all structural failures in construction projects. With diverse geographical and climatic conditions affecting soil characteristics across the country, from the alluvial plains of the Ganges to the rocky terrains of the Deccan, the need for comprehensive soil analysis cannot be overstated. In this video, we will navigate through the various types of soil investigations, highlighting their pivotal role in ensuring that every foundation laid is not only strong and safe, but also cost effective and suitable for India's unique landscape. Let's dive deep, quite literally, with subsurface soil investigations. Imagine constructing a building only to find it settling unevenly after a few years. To prevent such disasters, geotechnical engineers conduct test borings. These are essentially soil samples taken from various depths to understand the layers beneath the surface. But how deep and where should these borings be? Typically, for uniform soil conditions, borings are spread about 100 to 150 feet apart. In more complex terrains, this distance might reduce to 50 feet to capture the variations in soil composition and structure. So what do these borings tell us? A lot actually. They reveal the soil classification, moisture content, and even the depth to underground water. Importantly, they help estimate the bearing capacity of the soil, that is how much load it can safely bear. This information is crucial for designing foundations that won't give way under the structure's weight. Additionally, the reports include recommendations for foundation design, ensuring that the building remains stable and secure. Moving to the ground level, surface soil investigations are equally pivotal. Sometimes the clue lies right on the surface. Whether it's a high water table indicating potential moisture issues or the presence of peat, soft clay, or loose silt, each has its own implications for construction. For instance, encountering rock close to the surface might mean stronger support but tougher excavation work. So look around, the landscape tells a story. Rock outcroppings, the type of foliage, and even the terrain shape, be it a ridge or a valley, provide valuable insights. These indicators help anticipate challenges like drainage, erosion, or soil stability, guiding the choice of foundation type. For instance, steep terrains suggest potential erosion and sliding soils, necessitating more robust foundation solutions. Now let's delve into the nuances of soil classifications and the intricacies of plasticity and compressibility characteristics of soil. So spread footings are perhaps the most prevalent type of foundation used in buildings, particularly where the soil has a sufficient bearing capacity at shallow depths. They are simple in design, consisting of concrete pads that spread the load from structure above to soil below. Spread footings are versatile and cost effective, making them a popular choice for low-rise buildings or substructure with moderate loads. The area and depth of these footings are determined based on soil bearing capacity and the load of the structure, ensuring a safe and stable foundation. Drilled piers or caissons are deep foundation systems that are ideal for situations where the soil close to surface lacks adequate bearing capacity or is too expansive. These cylindrical columns are drilled deep into the ground to reach stable strata, effectively bypassing less suitable soil layers. Drilled piers are particularly beneficial in transferring heavy loads from structures like bridges or large buildings to deeper, more stable soil layers. Their design and depth are tailored to the specific conditions of the soil and the load requirements of the structure, providing a robust foundation solution for challenging soil conditions. Pile foundations come into play in scenarios where neither spread footings nor drilled piers are viable due to extremely poor soil conditions or very heavy loads. These long, slender columns are driven or drilled deep into the ground to transfer the load to a stronger soil layer found deep below the surface or to distribute the load along the length of the pile through friction. There are two main types of pile foundation, that is end bearing piles, which transfer the load to a firm layer of rock or dense soil, and friction piles, which rely on load bearing capacity generated by friction of soil along the sides of the piles. Piles can be made from timber, steel, or concrete and are chosen based on nature of load and specific conditions of the soil. Mat foundations, also known as rough foundations, are used when loads from the structure are so heavy or the soil is so weak that conventional foundations like spread footings or piles are not feasible. A mat foundation is essentially a large, thick slab that covers the entire footprint of the building, distributing the weight over a large area. This type of foundation is particularly useful when the soil has low bearing capacity or is highly compressible. By spreading the load across a broader area, mat foundations reduce the stress on the soil and prevent excessive settlement. They are typically reinforced with steel to handle the substantial loads and to accommodate the tension stresses generated by the bending of the slab. Foundations are not merely the first step in construction, they are a pivotal part of any building's longevity and safety. As we conclude our discussion on the critical importance of soil investigation in foundation construction, let's emphasize that understanding the underlying soil is not merely a procedural step but a fundamental necessity for any construction project. Proper soil analysis provides an accurate picture of the bearing capacity, potential for soil settlement, and presence of problematic soils, among other vital factors. These insights are crucial in guiding engineers and builders in selecting the right type of foundation that is both cost effective and suitable for the specific soil conditions of the site. It's an investment in project's future, safeguarding against unforeseen complications and ensuring that the structure stands firm against the test of time and nature.